in 6 different stations today. The first 3 in the morning, you guys are going to travel around the wetlands and learn about what makes a wetland special, some of the plants, animals, and soil types we have here in the wetlands. And then in the afternoon, you're going to learn about the importance of them, why it's important to conserve them, and what we can do to protect them. Things like, and you're going to do a little bit of science out there in the other part of the park as well. But right now we are at the soil station. And one more thing before we get started, you have this nice clipboard here, and this is going to be your data recording sheet. So can I have a volunteer to be the record keeper for this?
Oh, they already volunteered me.
Perfect. Well, you're going to be great. So you're going to take this to every station, and you're going to write. This is going to be your recording sheet for the whole group. So whenever you want to record something, whether it's the animals you're seeing, the plants you're noticing, or the soil types, we are going to record in this sheet, and you're going to want to be on the 2nd page because soil starts on the 2nd page. So, and you don't have to record anything right now, but just be aware that this is the case. So I'll let my assistant back there introduce himself. He will be helping us today.
Hi, I'm Mr. Lou.
Hello,
Say hi, Mr. Lou.
Hey, Brody.
Lou.
Excellent. So, so now that Will's on the right page, we are going to get right into it because we have a lot to cover and a lot to do. So let's talk about soil. What is soil? I'll take anything. Yeah.
It's dirt in the ground.
It's dirt in the ground. Very good. What else? Yeah, Ethan.
It's dirt in the ground that can store water, and it also goes down deep in the ground, and it constantly makes rocks. So somehow dirt goes down, and from the rain, when it goes down to the water, it creates rocks. And it creates rocks.
Excellent, very good. So you said a lot there, yeah, and we're going to talk about all of that. So it goes very deep in the ground. It can create rocks at certain levels. When the rain can travel through it, we're going to talk about how water interacts with soil. What else? Anything else? Anyone have anything? Yeah, Zoe.
Helps plants grow.
It helps plants grow. That's the other one I love to hear because that is such an important part of soil. You see all these plants around us, none of them would be here without soil. And they all require different soil types. The plants in one area typically require 1 or 2 types of soil that are found commonly around there. And we're actually going to talk about the ones that are special here to the wetlands. So when we talk about soil, we can characterize it in a lot of different ways. And one of the easiest ways to do it is about what it's made up of, what's inside it, what we have, what a majority of the particles are. And there's 2 big categories we separate that into. We have mineral and we have organic soil. So when I talk about mineral soil, what do you think mineral soil has a lot of? Yeah, I'm not sure of that. It's somebody.
Minerals.
Minerals, very good. Are you going to say that too? Okay, what are minerals?
Oh, wait, hold on. We learned this in science class.
Ethan.
Minerals are like tiny particles of all these different rocks.
Excellent, very good. Minerals are tiny particles of all different kinds of rocks. And sometimes minerals can be big too. Have you guys seen quartz before?
Yeah.
Yeah, so that is also a mineral. Sometimes you can go into caves that have really big mineral formations. So minerals can be very big. They can also be very small. And you're exactly right. So when we're in soil, we're talking about soil, usually the minerals are really, really tiny. Yeah.
You can see them in like caverns.
Exactly. Yeah, so you can see them in caverns. Maybe if you've seen a geode before, it's like it looks like just like a normal rock on the outside. You crack it open, it looks really pretty on the inside. Minerals there as well. So they have physical and chemical properties, but they're not living. On the other side, we have organic soil. What do you think organic soil has in it? Well,
Living organisms.
Living organisms. Excellent. Give me an example.
Coal, for example, because coal is made of other living organisms.
Very good. So coal comes from, it does come from organisms, and it typically is, but it is considered a rock, only that it's been formed a long time ago. But that's very good. So we'll talk about that later, but keep that in mind. So what are some actual living organisms or recently living organisms that might be found in soil? How about someone in the middle here? Do you have any ideas? Okay. Jonah? All right, well.
Worms!
Worms, excellent. I'm sure you've all seen worms in the soil before. They're a big component here. What else?
Worms are our friends.
Anything? Paisley, what do you think? What's on the ground right here? What's all on this ground?
Leaves!
Leaves, very good. So we have leaves in the soil, and we have a special word to describe that when leaves are decaying and decomposing into the soil, and that is litter. So you all know what littering is, right? When you throw trash and gun, you shouldn't do it. But there's a natural process that creates litter as well. And it's when trees, especially this time of year in autumn, lose their leaves, and the leaves fall down like this on the ground. and as decomposers break them down like worms and invertebrates, and if we have time we'll talk more about that. Fungus, very good. They turn into soil, so that's how we get a lot of organic soil. So we have organic and we have mineral soil. What kind of soil do you think we have in the wetlands? Organic or mineral? Yeah.
Organic.
Organic, very good. There is a lot of organic material in the wetlands, so and that's really important for animals and plants that live here. All right, there's a little hornet. It's okay.
Yeah.
Just get him off. We don't need this sheet. I'm gonna put this down. He's probably just thirsty, and it's really cold out, so he's not gonna get crazy.
Yeah.
All right.
So my family has a bee infestation, and those bees look just like this.
Yep. This won't hurt you, especially he needs to warm up too. So.
Also, my dad made a really good natural bee killer.
Oh. All right, tell me about it later. Hold on to that because we're gonna talk a little bit more about soil at the moment. So we have another word to describe the layers of soil. I'm sure you know that soil comes in layers. Maybe you've seen a picture of different layers of soil before. Do you know what that word might be? It starts with an H. I guarantee you know the word, but maybe not in this context. All right, I'll give it to you. So the word is horizons. Have you heard? You know what the horizon is? What's the horizon? So.
Isn't it like parts of soil that I guess help a plant grow in different ways?
Sure. Yeah. You were exactly right with this definition. I just meant what is the horizon in the definition you normally think of. But yeah, well.
Horizon is like the line where the land meets the sky.
Exactly. So as Will said, the horizon when we normally think about it is where the land meets the sky. The sun, when it sets, we say it goes below the horizon, that really far off line. Now, and then Zoe was completely right. Horizons are these different layers of soil that help plants grow differently. And if you see here, we have this chart. So at the top we have the organic layer, the surface layer, and the subsoil. And all of these, you can see there are roots in them, right? Everyone sees the roots here. So you see a lot of roots up here, a lot of roots up here, a lot of roots up here, and then less roots down here. Once you start getting into the subsoil, there aren't as many nutrients, all those important things in the ground, and less plants seem to grow here. So we have a lot of trees and plants with tap roots that go really, really deep, that tap into the water sources down in the ground. And then below here we have the substratum and the bedrock. Is there a lot of living stuff in here?
No.
No. This is there isn't a lot of life down here. Now there are a lot of microorganisms that can actually eat the rock with chemical reactions. It's really cool. But we're not going to talk too much about those. We're going to focus on stuff going on up here. So this is more the mineral layer down here at the bottom. We talked mineral and organic. Now I actually have a picture of real wetland soils here, and so one of these is a wetland soil and one of these is not. We have, this is number 1 and this is number 2. Which do you think is the wetland soil? So 1 and 2. All right, I'll say it on 3. 1, 2, 3.
1.
Oh, interesting. It's actually number 2. So, why did you think number 1? I'm curious.
I don't know.
Yeah.
Because it kind of looks a little drippy in it, and
Wait, I pointed at this one for 1, right?
yeah.
Okay, yeah, just checking. Yeah. All right, so one way we could tell that this one is the wetland soil is because it has a really high organic layer. So if you look here, you can see all the sticks and leaves and things in the soil, and that contributes to this high organic layer. The organic layer on this first one is really shallow. It's not that long, and so this would be considered a non-wetland soil. We actually have a special word to describe wetland soils, and that word is hydric. Everyone can say hydric.
Hydric.
Hydric, very good. So it's H-Y-D-R-I-C, hydric. You're going to learn some other words at those other stations that are going to be very similar, and they all have to do with things that like to live in wetlands or a descriptor for things that do live in wetlands. So we have hydric soils, and we have wetlands that are super important. They're full of organic matter, and now we're actually going to get into the soil itself, and we're going to start by talking about the different things, components that make up the soil. So we have different things called substrates. You know what substrate is?
No.
So it could be used as another word for soil, and it has to do with the types of particles we have in it, because soil is made up of a bunch of different particles. Are you okay?
Yeah, okay. I was just saying the pencil out of it.
Okay. You can leave it on the table for now because you don't need it at the moment. So we're gonna do a little activity, and we have 1, 2, 3, 4, 5, 6, 7, 8. So I'd like the 3 of you over here to stay on this side, and you are going to be our water in this experiment, okay? And then the 5 of you are going to come over here on the path, around here. Perfect. And you are going to be our substrate. So you're gonna start out by being sand, okay? So everyone put your arms out like this. And You can touch them when you're too close. But you don't want to. We don't want to leave a space. We need to be like sand. We need to be random. You kind of like sort yourselves kind of randomly in there. Yeah, that's good. Better. Excellent. That's good. And I'll stand right here. All right. So in this example, we're going to see how water interacts with different substrates. And in this case, sand is a really big particle. In terms of soil, it's quite big because you can actually count individual grains of sand. It would take a while. Maybe you need a magnifying glass, but you can see them with the naked eye. And so they're quite big. All right. So we're going to put our arms at our sides. Water, come through us. Your goal is to get to the other side. That was easy. It was easy. It was very easy. So, and that's because there's so much space in between the particles. If we're sand particles, it's really easy for water to come right through. Okay, we're going to be the next particle now. We're going to be silt. Have you guys heard of silt before? Have you heard that word? Excellent. Where might you find it? Yeah, you're exactly right. Sure, yeah. So it could be mixed in with gravel. Yeah, exactly. That's a great one too. So it could be in gravel, it could be at the beach. I like to think of it when you go to a pond or maybe a really slow-moving creek, and then you stir up the bottom and all that nice brown stuff starts floating in the water. A lot of that is silt. It's a much finer particle. The particles are much smaller, but they aren't the smallest thing out there. And they're very soft typically too. So we are going to be silt now. So everyone, my substrate people, arms on your hips, like Superman. Excellent. So get a little closer now. We're going to turn away from each other because we don't want to breathe on each other because of COVID and stuff. But make sure you're a little closer. All right. Water, you may come through, and soil, drop your arms. So you put your arms on your back. Oh no. Excellent. So was that easy?
Yeah.
Still easy. Was it a little hard? You have to go a little slower. You had to go a little slower because we were closer together. When the particles are closer together, the water doesn't go through as quickly. All right. One more. We have one more substance. We're going to be clay. So everyone knows what clay is. I'm sure you've played with Play-Doh, you've played with something like clay. Yeah? Yep, so it's very similar. So clay is made up of really fine particles and they're really super compacted. They're all super close together and you can mold it, I'm sure you've done something with that before. So this time we're gonna put our arms at our sides, and again because it's COVID we're not gonna completely bunch together, but I want everyone a little closer this time. Turn away from each other, that way you're not breathing. And it doesn't have to be a line, don't do something, you random a little. There we go. All right, perfect. All right, water, see if you can get through us without touching. It's fine if he wants to. Nope, if you touch, you gotta go back. Or you gotta find another way. You can. Will did something, yeah. Oh my goodness. What does it mean? Yeah. Excellent. Very good. So that is half of it, and the other half, they demonstrate the exact purpose. So, did you guys cheat when you went around?
No.
No, you didn't. You illustrated the exact principle that we're talking about here. So when the particles are so fine that water can't get through, it usually goes around. So what you did was completely natural. When water can't get through clay, and now clay has water in it, but it can't soak up a lot of water. It can't carry a ton of water in it. A lot of that water will just sit on top, or if it's moving downhill or into the ground, it'll wait and then flow around to find an easier path. So what you did is exactly what we're looking at here with soil. When we have really fine soil, it'll just typically, the water will hit it and then move around. And maybe some little particles can get through because every once in a while, there's one kid who will crawl down. Yesterday, someone actually crawled through someone's legs to get through. Not sure why. All right, so we know now a little more about sand, silt, and clay. Let's actually see some and manipulate some. So I want everyone up here on the boardwalk.
Hey, Fred, clipboard.
All right, no, you don't need the clipboard just yet. All right, so we are going to reach down. We're actually going to take some soil. Take a little piece about this, this much soil in your hands, and then meet me back at the table over there. All you need is a little piece, and then you can come back here. This is our wetland soil right here. What did I call wetland soil again? So it's an H?
Oh, horizons.
So horizons are the layers. What? Oh, close. Hydric. So everyone say hydric. Hydric. Okay, if you learn one thing here, it's that hydric soils are wetland soil. So we have our nice soil here. I want everyone to take like a minute or so and then tear it apart. Like, see what's inside. Are you finding anything in your
I
soil?
found roots.
Roots, excellent. Grass. What? Oh, a stick, great. We have a stick, roots, grass. I have a leaf in mine. Anyone find a worm? Sometimes people find worms in their soil.
I love that. I got no worms.
No, that's okay. Sometimes there are, sometimes there aren't. So we have some roots, some grass, and those are all organic compounds, right? So we have organic soil here. Now, we actually have a nice flow chart that's gonna help us determine what type of soil we actually have here in the wetland. And the words are really small, so I'm just gonna walk us through it. But you can see it here if you'd like, and later you can look at it. All right, so we're gonna start. We have our soil in our hand. Can you form a ball with your soil? Can it hold its shape? It doesn't have to be a ball, it's more, can it hold its shape in whatever shape?
Yeah,
I like
it
to
can.
form mine into a cube sometimes because I think that's kind of fun.
Yeah, it can.
Perfect. So we all can form a ball. Excellent. All right. Now we're going to try to form it into a ribbon. This part is a little confusing and it doesn't always make sense. What you want to do is you're going to press it between your thumb and your fingers here and see how far you can press it out before it starts cracking like this and before a piece, like a piece like that. Oh no, I can't push it that far. So we're going to decide
I got mine, but it's already.
well, it has to be a little thinner. So if you, Will, you actually have a lot. So take some of it out of your hand.
Like this?
Yeah. It has to be thin like this. So you're trying to get it super thin. Yeah. So those of you with smaller pieces. Oh, Paisley has the right idea. Yeah. So just a small piece and seeing how far we can push it
Is
out.
this better?
Yes. There. That's what you want.
It's still not cracking.
Well, so yours also has to do with the size. So if you have you have to have something more like this size to do this chart correctly, but you have the right idea. So you can kind of scale it upwards.
All right, I'll just take off
Yes,
the
like
small
that.
piece then.
So we can form a ribbon, right? So it can flatten itself out and still hold its shape. And I'd say this is a little over an inch. So we're down here, and we have one more task to do. So you need to take a really small piece of your soil like this,
Mine's still not cracking.
and then yeah, just take a small piece now, and then kind of manipulate it around your hands, squeeze or in your fingers, squeeze it, see what it feels like. What are you feeling? Interesting. Why is it interesting?
I feel like roots.
Roots, excellent. So yeah, we're feeling some organic matter. What else did you say? Sandy.
Mine feels
very
like
good.
wet Play-Doh.
Wet Play-Doh, very good. So we are feeling some grit, right? It's a little gritty, but would you say it's mostly gritty or mostly smooth?
Mostly smooth.
Mostly smooth. So we have mostly smooth soil here. And when we have mostly smooth with a little bit of grit, but it's mostly, we have some silty clay loam. So we have silt, we have clay. We talked about those. Silt's the medium particle, clay's the really small particle, and that's how you can make it, we can turn it into a ball, we can form it. That's how we're getting these shapes. We have silt, clay, and we have loam. Does anyone know what loam is? I have another diagram here for you. Here we go. So this is a soil chart, and we use this to determine what percentage of each type of particle is in our soil. We have clay up here, we have silt, and we have sand. And here loam is in the middle. So what do you think loam is?
The most middle particle.
So it's actually a mix of all of these. So these are the part and how much of each particle goes in. So loam right here in the middle shows us that we have true loam is about an equal amount of each particle. But since we have silty clay loam, that means we have less sand and more silt and clay in here. All right, there's one more test I want you guys to do. So we're gonna pull down our masks and sniff the.
Oh, I can pull it out of my mask. Get my hand.
Try to pinch it like this, between your fingers like this, and then pull it down a little. There you go.
It stinks.
It stinks. Does it stink? I kind of like the smell of it.
Yeah, it smells really good.
Right? It smells. Well, some people think it stinks. That's fine. So it does smell, right? It has an odor. Would you classify that as organic or mineral?
Organic.
Organic, yeah. Minerals are kind of harder to smell. I don't really think. A true mineral probably won't smell very much. You can have sulfur or something like sulfite, but typically you're not gonna smell a quartz and be like, oh, it smells like quartz. Maybe minerals might tickle your nose a little, but this organic really has that strong, like just after it rained or you step on grass, like wet grass or something. That's the organic smell we have. So we have an organic smell. All right, we're actually gonna get down. It measures the pH. Who knows what pH is? Have you heard that before?
How acidic something is.
Very good. Is that what you're gonna say, Zoe?
Is it like water level?
It may have to do with water level, but Will's right. It is how acidic something is. So Will, do you know anything else about the pH scale? Do you know what the numbers, it goes from?
0 through 10.
Very close. 0 through 14. So so something is 0, something is 14. And do you know the opposite of an acid?
A base.
A base. Very good. So we have 2 words for that. We can say base.
If you have a pure acid or a pure base, it will disintegrate something.
Very good. Yes, and that's a good point. So, and I'll talk about them more in a second. But we have acids and we have bases, and you can also say something that's basic is alkaline. Everyone say alkaline.
Alkaline.
Alkaline. You'll learn that at another station too. So we have acids and bases, and if something has a pH of 1, is it acidic or basic?
Base.
It's acidic. 0 is the most acidic. So 0 is the strongest acid on the scale. And you can actually have things that are below 0, but they are like man-made substances and kind of weird. And then if something has a pH of 13, is it acidic or basic?
Base.
Basic, very good. So 14 is the highest base you can get on the scale. Again, you could go above, but not in most cases. Yeah.
So it can go down to negatives.
It can. There are some substances that do, but they're not traditional like things you're gonna find everywhere. It's like special cases. But in this case, we're gonna stay within a certain range because things that live typically need a relatively neutral pH.
Like
So if 0 is
7.
So if 0 is the most acidic, 14 is the most basic. What's neutral?
7.
7. Very good. What substance is neutral? Something we're surrounded by a lot.
Water.
Water. Very good. So pure water is a neutral substance, completely neutral. Seawater is basic. It's about 7.6, 7.4, around there. So it is a little basic on that side. Our blood is relatively neutral too. Sometimes your pH can go up a little basic as well. It can be around 7.2 or 7.3, but it's typically pretty neutral. Yes.
Why is it just like a different blood type? It will still be neutral?
Yep. So the pH isn't necessarily affected by blood type. All right. So we want to measure the pH of our soils here. And the way we're going to do this is you're going to get in groups of, let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8. So we're going to have 2 groups of 3 and 1 group of 2. And what you're going to do when I'm done talking is, I'm going to flip this just for a second. You're going to, each group is going to need a stopwatch and a Kelway meter. And I just hand sanitized when I got here, but you guys should hand sanitize before, not right now, but before you pick up these instruments as well. You're gonna take these and you're gonna take it over there, and what you're gonna do is you're gonna stick it in the ground, and when you stick it in, you gotta make sure that all these metal plates are completely covered. Is that part clear? Because if they're not, it's not gonna read it correctly, and you're gonna have a wonky measurement. And do not worry about this button at the moment. We're gonna do that later. So just stick it in, and once you stick it in, you're gonna start your timer. You're gonna start it for 2 minutes. At the end of the first minute, you're gonna tell Will your number, and he'll record it, and Will, I'll help you with that. So we'll learn how to do that. But you're gonna tell Will your number, whatever the top number is on this chart. So there's one that goes from 3.5 to 8. That's the one we want. And then below you'll see smaller numbers that go from 0 to 100. That's the moisture, and we'll do that second. So whatever your number is after the first minute, tell Will, leave it in, don't touch it, and at the end of the second minute, do the same thing. Tell Will around it for the year. So if it's like, if the average temperature is like 50, around 50s, around here you probably have 55, 60, around that area. For cave temperatures, what do we get?
Wouldn't like
So it is a little colder, yeah. So, oh yeah, go ahead.
Wouldn't in the summer it'd be like, if you're like at the bottom of a lake or something, it'd be colder.
Oh yeah, it would
Because
definitely be colder.
top water, a lot of fish, they like to get down in the bottom area of the water
Yeah.
in the summer because it's warmer. That's why
Oh,
it's
you mean colder, or in the bottom?
in the bottom because it's cold.
All right, we're gonna come back up here. For the past
Yes.
20 minutes. This is our wetland soil. You can tell that the color is really dark, the texture is really moist. Okay, we have this one over here. Where do you think this one came from? Yeah, Zoe.
probably like where you first come in.
Ooh, very good, excellent. So, so remember jumping up on the first time. So this actually wasn't right there, but this is a representation of that. So when we came, so it's actually when we crossed the bridge, and then we saw the cart. Remember I told you to remember the cart? This is where that came from, around the cart. So that's considered the high dry meadow. That's what Mrs. Smith or Earthwalker said. We have the high dry meadow soil right here, and again, the texture is different. You can see there's more grits. There's a little bit of sand in there, probably a lot more sand actually than what you're gonna find in the wetland soil. What about this one right here? Where do you think this is from? This one's kind of in between, right? Yeah.
Oh wait, like the power line section. It goes very muddy.
Yeah, you're yes. Any? Yeah, so actually you're right. So this is a pop-up wetland. So when we crossed the bridge and then we walked to the well, we crossed the bridge, you turn right, and then we walked past something that looked like a wetland, but it was kind of encircled. That is a created wetland. That was made by us here at Renfrew. And the difference is you can tell that this isn't natural. This wetland has been here for hundreds of years. So it's really good soil, really fertile place. Over here we have this pop-up wetland, and this isn't as efficient. Now this afternoon you're going to learn more about why it's important to have wetlands, what services they provide, and what they're useful for. But do you know one? Yeah. What's an example? Yeah. Exactly. That's perfect.
We want
Yeah.
the Bill Nye video.
I'll come back here now that I know too. I'll come back here.
Yes, exactly. So if a flood comes in, then it can hold in a lot of water. This one probably won't hold in as much water. You can see here, this one still holds a ton of water. This good wetland, this pop-up holds more than the high dry meadow, but not as much. So that is one service you'll learn about more. But it's important to note that the soil. So when you learn that, think back to this station and think about how the soils are different and maybe how that affects how good your wetland is.